Welcome guys to my first video. In this tutorial, we will create an easy procedural module-based room generator, just by simply putting the desired length and width for the room, and it will automatically generate it. As you will see, each tile is a fully customizable actor, so you can attach objects, change meshes, spawn enemies, or maybe treasure chests for your dungeons, buildings, or rooms in your city. Okay guys, so let's start with the tutorial. First of all, I wanted to show you the mesh that we are working with this time. This is a 200 by 200 by 40 centimeters tile, and we will be using it like as a floor, as a cell for the grid, and also for the walls. So let's create our modular actor. Let's call it modular actor. Remember that this is a modular based room generator. So let's open it up and let's add a mesh, a static mesh. Let's call it just mesh. And please verify that the location, rotation, and scale, all the transforms are in the default value. That is 0 for location and rotation and 1 for scale. Let's search for tile, compile, and this will be it for now. This will be it for now. Now let's create our room spawner. This will be the blueprint that will create the grid like as we need. Let's call it our room spawner. And this will be calling as many modular actors as we want. So let's start with our first function. Let's call it cell spawner to spawn each cell of the grid. Spawn actor for class. Let's put a spawn actor for class or modular actor. Let's split the transform. Let's search for our mesh reference. We need to set our relative transform. Oh, set relative transform. Also for static purposes, we need to set our material. And also set our static mesh. Because of the modular behavior, we can just put any mesh we want. That is I don't know, like a window or a wall with a door, etc. Let's set some values. First of all, we need to create an input with the spawn location of the actor. Then we need to create another input for the rotation of the mesh. Because for each cell of the grid, we don't want to rotate the entire actor, just locate it. Whereas with the mesh, we are just interested in the rotation, depending if, yeah, it will be a piece of floor or a wall, etc. Let's select any material. In this case, let's the basic shape material. And also let's create another last input for our new mesh. This will be for selecting, our mesh, the mesh that we want. And last but not least, let's save this spawn actor, this modular actor, in an array. Let's create this new variable called, I don't know, base grid actors. Then let's create another function that will be called our grid generator. Our grid generator, first of all, we need to create a variable that will serve as the offset for the for our mesh. The offset in this case is the distance between the center of each actor that equals to the length of the side of the mesh, because it is a square tile of 200 by 200. So let's create the variable. Let's add an input. Let's call it the cell size, the cell size. Then we just need a two for loops. Two for loops connected, one for the x and y, and one for the y axis. And the last index will be a subtraction of a number, in this case an input, called I don't know, grid x, minus 1. And the same will happen with the y. It's, in this case, the grid y minus 1. Okay, let's call our cell spawner. Let's create a variable called our mesh, a local variable, I don't know, a variable called mesh. It's okay. Let's find our tile. And this, and for the spawn actor location, we need the sum of two values. That will be the current actor location, get actor location. Okay, let's make an vector with the transform, the location transform. Let's and this will be connected to the index for each axis. In this case, x and y. The z, we are not using that because we're just interested in the dimensional axis. Okay, so let's grab the y and let's multiply by the offset. Let's connect in the y, and the same will happen with the x. Okay, let's compile. Let's call our grid generator. Our cell size, that will be in this case 200, because it's the length of each side of our square tile. And also let's create some uh, variables to expose on spawn and make it instance editable too. Let's drag our room spawner. Let's create a grid of I don't know, 4 by 4. Let's run. And yeah, it's working. F8 to detach from the character. 1, 2, 3, 4 by 1, 2, 3, 4. Okay. Currently it is working, but we're not done yet. We need to create our in our modular actor a function called to see the availability of each of the sides of each tile. So in this case, let's call it get vector offsets to see which side is available to spawn a wall and which sides are not available because they're overlapping. They're overlapping with another tile. So there will be a diagram I made to exemplify this to explain. I'm sorry to explain better this situation. So it will be anywhere in the screen. Um, so okay, let's create our first local variable that will be our current offset. It will be a float. Let's drag it to our diagram. Let's create our for loop. This is the best way I found to describe the behavior of this table I have come up with. The idea is to create an array with a length of 4, each one representing a different offset direction, with the following order: 0 for the front offset, 1 for the back, 2 for the right, and 3 for the left. That's why the loop will iterate from 0 to 3. And as you see in the screen, we need to change the values to from positive to negative from this D. That will be our current index. So the best way I found was to first of all detect if our first index is if our indexes are even or odd numbers. So if they're odd numbers, we need to change the sign of our current offset that to negative. Okay, let's multiply by -1, and if it's an even number, we don't do anything. Okay, let's create another branch that will separate the front and the back vector offsets of the right and the left offset. Okay, in this case will be if our index is less or equal to 1, that will be another situation. Then let's create another variable that will be called the current vector. Will be a vector. Let's make vector, and as our table says, the current offset, if it's the front and the back or the back offset, our current offset will be placed in the y axis, and if not, our current offset will be placed in the x-axis. Okay. Finally, let's create another variable that will be our array of vector offsets of directions to check if which direction, to check the location of each side of the tile. Let's call it the vector offsets, an array. Let's add the current vector value plus the current actor location. For that, we'll be using a. I'm sorry, we need to connect this input here. The offset and the actor location. So now we have the vectors of each side, the location of each side. Okay. Then we need to go back to our room spawner and create another function that will be called get side states. Let's put it there. And that will be looping through uh, each member of the base grid actors. Get actor location. Let's get the actor location, the current actor location, and then add it to an array that will be called the grid. I'm sorry, called grid positions. And also let's call the function we just made in modular actor, get vector offsets. Connect the current actor location and the offset. This will add the current actor location of each grid actor, and also the vector offsets of each individual modular actor will be filled in order to store the location of each offset. And last but not least, let's create our final function of the tutorial that will be called wall spawner. This will take the base grid actors, each of the base grid actors, and then we will call the vector offsets. We will get the vector offsets, and also another for each loop. Let's travel to each vector offset, and let's make a separation now to see which offsets are which offsets are available and which aren't. So if grid position contains the current element, if it contains the current element, that means that side is overlapping with another actor. Okay, with another actor, in this case another cell, another piece of floor. But if not, let's just spawn, oh I'm sorry, a a cell, I'm sorry, just the current array element. And let's use our tile, let's use your tile that we just created for this video. And we just need to put our wall spawner in the event begin play of the room spawner. Let's test this up. As you can see, it's working. It just spawned the walls, but they don't have the correct location. So the correct location and rotation. So let's alter these values. So in order to fix that, we just need to find the value in the array vector offset. And let's make some cases a switch case. So let's delete this pin, and let's create two local variables called relative location and relative rotation. Okay, let's all add all the cases, each case for each side offset, starting with the front and finishing with the left one. So let's create the cases. And finally, we just need to connect each case to the cell spawner, and the spawn actor location, we need to set another zone with this new relative location plus the the location of the current element. So in this case, as you can see, oh, as you can see, we made our room spawner with walls, so fully customizable and fully modular. That way you can, I don't know, put any kind of spawner in any of the tiles, or any kind of decoration in each wall. So I don't know, you can, that way you can custom your own your own dungeons, your own rooms, your own cities. I don't know. So to see if this is to exemplify more, let's create another another room of 8 by 9, just to just to see that it is working. And yeah, this is working because this is by its nature of by its modular nature, you can um, spawn the many room spawners as you want. Let's create here, the 3 by 2, and another one here, the of I don't know, 1 by 9, just to test. Let's run our simulation. Let's see. Yeah, as you can see, they are overlapping. I'm sorry, but they are working. They are working very fine. So yeah, that will be it for now, and I hope you find useful this tutorial. Feel free to comment anything you want and down there in the comment section. And thank you for your patience. This is my first time doing this, so uh, thank you for watching the video. Um, yeah, let's see you in the next episode.